Alright, so I know that I did this with you in the lab, but I think I'm gonna go through this again. So let's just take really quick the sum of evens. Let's see how can we do this iteratively. And just a quick note, if you can do something iteratively, you can do it recursively. See, the core of the problem is the essence that we're looking for. So let's say that we want to get the sum of even numbers up to the 8th element. Or, I'm sorry, we want to get the summation of even numbers. Yes, up to the 8th element. So we have something like 2 plus 4 plus 6 plus 8. So this is going to give you 20, right? So let's try this iteratively. Let's say that we have S, which is the sum, and let's initialize it with 0. One would say why 0? Because you're adding. So 0 is not going to affect anything. And this is something that you're going to need whenever you are returning from the base case if you're doing this recursively up to the very first recursive call down, which will be very down in the stack, right? So let's say for I in range, right? And we start from what? We start from 0, of course, right? And we want to go up until n in this case. Let's say that we have n here, right? 8, for example. And I'm gonna add 1 because if we want 8 to be included, then we want to add 1, right? So we're gonna stop at it's gonna be 9, we're gonna stop at 8, and this is 8 what we want to have, right? If you had this as odd, right? So maybe you have something like 7. If you added 1, anyways, 8 is not gonna be with you, and as well 7 is not gonna be with you. Why? Because you are stepping with 2, right? So let's try and say that we are going to accumulate that sum with the value of I, right? And let's try to print the sum. This is going to give you 20, right? If we have this as 7, for example, you're going to have 2 plus 4, which is 6, plus 6, which is 12, right? So this is not going to be any different if this was an odd number. Now notice something. I'm just going to rephrase this without this augmented assignment, right? This is my core problem. This is my core problem. This is the most important thing that happens whether I'm doing this iteratively or whether I'm doing this recursively, right? So if I wanted to do this recursively, I'm going to first of all take the first approach, which is using the call stack in this video, right? In the next video, I'm just gonna discard everything that I know about the call stack and just take this for loop and try to convert it into a recursive call. So if you want to stick to the call stack method, stay with this video. If you want to see immediately how can you do this recursively, then just have a look on the other video that we will do, which will gonna adapt the next method, which is basically without using the call stack. It's just converting iterative to recursively directly, right? So let's just go and open up the whiteboard and let's just clear the canvas here. And this is recording. All right, let's just flip the laptop. All right, so let's say that this is my my problem. I have n of 8, and I want to get the sum of evens up to n, which is 8 in this case, right? All right, so this is going to give you about 120, right? And this is going to be something like 2. Let's take it from backwards since we're going to do this recursively. So I'm just going to take it from the smallest to the greatest. So we have 2, this is the first even, and we have 6, and we have 8, right? And maybe we would add something like 0 at the beginning. It wouldn't really affect this, but let's just have 0 at the beginning, right? So, or you know what, let's just discard that 0 for now. All right, it's gonna appear by itself. All right, so I'm just choosing to start from the greatest element up to the smallest element, or the smallest even in this case. There is no fixed rule that is telling you you should start from n that the user will enter and start decrementing it to the last or the smallest even number, right? We can do it backwards like that. That's totally fine. And I'm going to show you how can we reverse the algorithm if you wanted to start from the smallest element to the greatest element once we do the code into once we code this kind of algorithm first, right? Then I'm going to show you how can you tweak it in order to have it from the smallest to the greatest. But anyway, let's take this approach, and you know that by the end of the submission, you're gonna have the result. If we have n that is equal to 8 in this case, you're gonna be having a result of 20, right? So if you think about it slowly, and if you try to if you try to truncate these problem into subproblems, into chunks of smaller problems, you're gonna see that you start in, if you're starting from backwards, if you're starting from the n that the user will enter, so you're starting in from 8, right? Plus a couple of stuff that we are not really familiar with for the time being. This is the unknown part for me. I know that this is going to be 6 plus. The screen is not helping at all. I know this is going to be 6 plus 4 plus 2, right? And I know that you know that, right? But in just a case where like the n is kind of an input from the user, it's gonna be 8, it can be 4, it can be 24. We don't really know, right? So what I'm sure that I know of this part of this kind of equation that I have, the known part for me is always the n that I chose to be the starting point, the n that the user will enter. This is where I'm going to start with, and dependingly I'm going to decrement in this case because I'm looking for evens. So if this n was even, I'm going to decrement with minus 2. So if you focus on my kind of speech that I've said right now, you're gonna see that I made a small conditional in between my words, and I said if n was even, then I'm going to start by decrementing this by 2. But what if it's like something like 9, as you're gonna see? This is odd, right? So if it's odd, I'm gonna make sure that n is gonna be decremented by 1, just to make sure that I'm starting from an even number, and every element that I decrement by 2 is gonna be accordingly an even number as well, right? So we're gonna leave this conditional here to later, but for the time being, let's just focus on the what is the known part, which is in this first recursive code, right? So this is gonna be n equals 8, or let me just write it on the other side. So this n equals 8, and this is the unknown part. And as I told you in the factorial program where we solve the same exact problem using this method, which is the call stack or the stack frames, right? I told you that the unknown part is typically where you are going to recursively call the same function, right? So this is indicating that this is the place for a recursive call for the same function, right? But this is the known part, which is going to be n in this case, right? So let me just remove all of these words for now, right? So the program is trying to find out what is this recursive, what is this unknown value. So it's going to go for a new recursive call, right? Where n is going to be, in this case, come on, n is going to be 6 in this case, right? So we have n that is equal to 6 plus an unknown value that is going to be fetched and known eventually once we start going back these kind of stairs that we are going downwards right now, right? So the unknown value, I know that this is going to be the resultant of 4 plus 2, but for the time being, let's say that this is unknown for the program, and for the program, the only known thing is this n part, right? So here n is equal to 6, right? So in order for the program to figure out what is this, so it's going to go for a new recursive call, right? Where n is going to be equal to 4, right? So we know that here is n is equal to 4 plus, I know that this is 2, but this is, let's say that this is still the unknown for the program, and we can go another recursive call and say that recursive call 4, where n is going to be 2, right? This is gonna have the value that should align everything up. Let's say that we are not gonna stop the base case at 2, right? We can say this. We can say if in that recursive call, if n became 2, which is if I'm looking for the sum of evens, then the smallest even is gonna be 2, right? So if n became 2, then just return 2, right? Something like this would work as a base case, and typically this is the better base case than the one I'm going to suggest right in a minute, right? So if the recursive call had n in it, if that recursive call, if that function now is accepting n to be 2, then this is an indication that I should actually start aligning the pieces from that recursive call, right? So if n is 2, I can just say now that I am going to return 2, right? So I'm just returning 2 here, right? And once this 2 is returned, then I know that this is, which is equal to 6, is going to be returned as well here, and this is going to be equal to 12, is going to be returned into this guy right there, and 12 plus 8, this is going to be returned as 20, right? So this is if the base case was at RC4 or recursive call 4. If we wanted to go deeper into this, which I don't really recommend, but you can still go and you can say something like that. Let's say that I can say that in this case I have n that is equal to 2, and this is not my base case, right? So n here equals to 2, and there's still some unknown that I'm not familiar with, right? So in order to find out that unknown, I'm gonna go for a new recursive call, right, where RC is 5 now, and n is gonna be decremented by another 2, so n is 0. Here, this can actually be my other base case, right? The unadvised one, right? So you can say if n is found to be 0, right? We can just say return 0, right? So in this case, if recursive call is n 0, then I'm just gonna return 0, right? So if I'm returning 0 to this guy, so this is gonna be 0, right? So this is gonna be returned as 2, right? And this is gonna be returned as 6, and this is going to be returned as 12, and so on. So nothing is going to really happen, but the catch is that you added a new recursive call to the stack frame that you didn't really need, right? But if you wanted to have the base case add this recursive call at the 5th recursive call, it's still up to you. But if you can't do it, like if you can minimize the number of recursive calls at least by 1, this is going to be an increase to your performance of the algorithm, since this algorithm is simple, and maybe you have some algorithm that's going to be a little bit difficult to handle, or have some complex operations that's happening inside that algorithm. So being able to decrement the number of recursive calls is a good thing. Now let's just delete all of this and do the stack frame thing, which is basically an application to all of what we have just said. Alright, so I'm just gonna stop where this is my actual base case. Alright. And this is already recording. Alright, so let's really quick write our stack frame, and you can tell that there is 4 recursive calls, right? And you didn't have to do this staircase thing that I'm doing. You can just look at the number of evens that you are going to traverse. These are 4 evens, so this is roughly going to give you recursive calls of 4 recursive calls, or a number of 4 recursive calls. So I have, this is 1, 2, 3, and 4, right? So let's say that this is, right? And let's say that this is my main script. This is my main script, right? Where main.py, right? Where I'm going to call this, let's say I have the definition here, and this is my driver code, right? So this is the function definition, and let's call it SumEvens, and it takes n. Right, so following the golden rule that we have settled in the factorial program, we have the same, since this is recursive, we have SumEvens being called again, but the parameter needs obviously to be changed. So this is changed into n minus 2 in this case, right, because we are stepping by -2 as a step. And from every recursive call, as you're seeing, there is a return that is really important. From every recursive call, there is a return. From every recursive call to the one before of it, right, there is a return. From every other recursive call, like this is gonna return something, and this is gonna return something, and this is gonna return something, right? So all of these recursive call, all of them should return by the end of the day something, right? So there is an important return here. This is the permanent return. When do I have a permanent return? The answer to this is that you have a permanent return once you say you have a program that wants you to calculate some value, right? Or returns some value. It's not only about printing, it's just about returning an actual value that I can print, right? So this is the permanent print here, and this is my base case where if n is equal to let's set it to, you know what, let me just set it to 2 in this case, right? If it equals to 2, then I'm just gonna return 2, right? And the conditional where I told you, if we have something like, if the user enters something like n is equal to 9, right? We cannot just like immediately start decrementing this 9, which is odd with -2. You're gonna have 7 and 5 and 3, so this is not gonna work. So we need to make sure that the number is actually an even number. So if I divided this by 2 and I found out that it's not equal to 0, which is equal to 1 in this case, meaning that this is odd, then I'm just gonna change the value of n into n minus 1, right? So this is to check or make or convert the n to even, right? So this is the body of the function, and this is the conditional return, which is, this is my base case right there. And in the driver code, I just want to have n that is equal to 8 for this example, and say that SumEvens is gonna have 8, and this by the end of the day should return 24, which I'm going to print, and to the screen or the terminal I want to see something like 20, I'm sorry, 20, just 20. It's gonna return 20 like that. All right. So in the first function call, where we start calling the actual function, this is the first recursive call. So this is SumEvens. That's gonna take place here, where n is actually 8. So this is SumEvens. This is the function definition of 8, right? And we have the base case, and we have the conditional where it converts things to even, and finally we have the permanent return, which it should return the same looks that we have, which is n in this case, and the recursive call to the same function, right? So n in this case, and you see that there is an addition here because we're looking for additions. This addition here and there, right? Plus the recursive call for SumEvens, right? But n minus 1. In this stack frame, I have n that is equal to 8, right? So when the compiler checks this if statement, well, n is not equal to 2 yet, and n actually is divisible by 2, so this is not gonna take place, and this is not gonna take place, and when the interpreter goes to this line, it's gonna evaluate n with, it's gonna substitute n with 8, but this is gonna open up a new, it's gonna trigger a new function call to the upper stack frame. So this is, if this was my top at the stack frame, this is now my top, right? So it's gonna trigger a new call to SumEvens, where this is equal to, if this is n and this is n minus 2, then this is gonna be 6. So n here is 6, right? The conditional is not gonna work. The other conditional is still not gonna work because everything is even in this case. Oh my goodness, my screen dies at this portion of the laptop, so it is 6 in this case. All right, and the third line, which is the return of n, this is going to be substituted by 6, of course, plus, come on, don't do this. All right, plus SumEvens n minus 2. Right? So this is gonna trigger a new function call to SumEvens. So this is, if this is recursive call 1, this is recursive call 2, and this is not the top anymore. This is my top, and this is recursive call 3, right? Where you are calling here SumEven 6, and this is SumEven, yes, you guessed it, 4, right? So n here is equal to 4, right? This line conditional base case is not going to work. This can the other conditional for converting to even, it's already even, so there's no need for it. Let's go to the return, right? So return n plus some evens where n minus 2, right? So this is going to trigger, of course, this is going to be substituted by 4, and this is going to be triggering another function call where this is RC4 and this is my new top, right? So this is going to be triggering some evens of 2, right? And now with this if statement, if it's equal to 2, then just, I'm not going to allow you to break in this case. I need this to be written beautifully. That's not beautiful. Return, right? Return 2 in this case. I swear this is 2, right? This is 2. So return 2 in this case, right? So we're not going to go through that other conditional or that third return statement, because if one return happens, all the others are not executed, the other lines afterwards, right? So this is going to return 2. So this is the first return that's going to align the pieces. So once this is returning, it's going to be returning in place of the call that has triggered that frame to begin with, right? So this is going to be returning here. So this is going to be having 2 plus, let me just make this a little bit heavier, 2 plus 4. So this is going to give you 6, right? So this is going to return here in place, and this is going to, of course, pop from the stack, and this is going to be popping from the stack, right? So 6 is going to be substituted with the SumEvens here, the call that has triggered to begin with this part, right? So this is 6 plus 6, which is the n in this recursive call. So this is going to give you 12, right? Pop from the stack, and you have finally the last recursive call where this is going to be 12 plus 8. This is going to give you 20, and this is going to be popped from the stack, and this is going to be substituted with this guy, the original function call, and you're going to see 20 printed in the terminal. Whew, that was awful. All right, let's write this in recursively. All right, so SumEvens, and it takes n, and if n was I'm sorry, if n was equal to 2, so we're gonna return 2, right? So if the number was not even to begin with, right? If we divided this by 0 and it wasn't actually returning 0, I'm sorry, if we divided this by 2 and the remainder wasn't, there was a remainder to begin with, so this is odd, so we're gonna just say n minus 1, and you could just say equal 1, it's the same thing, right? So return here n plus SumEvens n minus 2. So let's say that we have n that is equal to 8 and SumEvens, and pass that n and just print, this is going to give you 20, right? And if you wanted this to have like 0 and return just 0, then it would still work, but you have added another stack frame that you didn't really need, right? So let's take this starting from 2 up to 8, right? The problem with this approach is that if you wanted to take it from the smallest to the greatest, we have one problem. The problem here is that if you are starting from the smallest to the greatest, like I told you that you can, take both ways. If I wanted to start from 2 up to 8, then you can do that, like the forward method, not the backwards method. But typically the backwards is kind of intuitive, because when you want to get the sum of evens, you pass n, right? And n can be my first recursive call, right? That I'm going to start with. So it's really easy to visualize or to imagine that if I'm starting with 8 with n, then all of these is going to be aligned with every recursive call returns a value. So it's kind of easier to think about and easier to implement, right? But if you wanted to take it like in a forward way of thinking, then you have, I think the loop is going to be the easiest solution for you, right? It's not going to be that obvious when you do this recursively, but you still can do it recursively, which I don't really recommend because, you know, this is, I don't want to say best practice or anything, but this is just not that intuitive. But if you wanted to take it from the smallest to the greatest, right? So a couple of things need to be changed. First of all, we're not gonna depend, we're not gonna be changing in here, right? So because basically you were gonna start with 2, then 4, then 6, then 8. So 8 is the number, or n is the number that I want to reach, and this is my base case. If I reached that to 8, if n becomes equal to n, for example, which is typically wrong to begin with, is you should return something like n, you should return 8, right? But this is not going to work. If you run this, it's just going to return 8 because you passed in, which is 8, and yeah, 8 is equal to 8. So this is not going to help you at all, right? So instead of depending on this variable, you're going to have an optional variable, which is in this case I, which is the same concept of a loop, right? Maybe this can be a little bit easier for people who are used to making loops. Like it's the same idea here. So you start I with regardless of that 0, you start I from 2, 4, and 6 up to 8 in this case, right? So you can have I as an optional parameter, and n is not going to be changed at all. N is just going to be sent for this kind of check, right? That I'm going to modify in just a minute, right? And every time you call that function, you make sure that you increment that I with 2, right? And the same condition here for checking if the number is odd and converting into even is applies, right? But in this part, you're gonna say if now I that I'm keeping on incrementing, if this is equal to n, then I'm just gonna return n. So if I reached when we incremented it to 8, which is equal to n that we have passed from the start, then I'm just gonna return 8. And in this case, I'm not gonna add n. Instead, I'm just gonna add I. And this is typically the same thing in the loop, right? In the loop, we have I that you are incrementing, right? And you have inside the loop, if you look closely, you have the accumulating value, accumulating variable, which is s, which is equivalent to this recursive call. This is what's going to be playing the role of the accumulating value or variable s inside the loop. So this is going to be what's going to be returned here. This is basically the accumulating value. So this is going to give you the same result, right? Seems a little bit fishy, but it works. But to me, this is basically more straightforward.